Determine all values of c that satisfy the conclusion of Rolle's theorem for the function f of x equals x to the fourth minus 4x cubed minus 2x squared plus 12x on the interval of -2 included to 4 included. The first thing to do is to determine whether the three conditions are met for Rolle's theorem to apply. The first condition, the function f of x, which is x to the fourth minus 4x cubed minus 2x squared plus 12x, has to be continuous on the closed interval given. Well, x to the fourth minus 4x cubed minus 2x squared plus 12x is a polynomial. And a polynomial is continuous on any interval, so it will be continuous on the closed interval given. Closed means that it includes both endpoints, indicated by the square brackets on both endpoints. Condition 1 is met. The second condition, the derivative, f prime of x, which will be first term power rule, bring the power down, subtract 1 from it. Second term power rule, bring the power down, multiply with the -4, subtract 1 from it. Third term power rule, bring down the power, multiply with the -2, subtract 1 from it. Fourth term constant times x, derivative is the constant. The derivative needs to be continuous. It's called differentiable on the open interval. Well, 4x cubed minus 12x squared minus 4x plus 12 is also a polynomial and is therefore continuous on any interval, so it will be continuous. It's called differentiable on the open interval. Open means it does not include the endpoints, indicated by the round brackets on the endpoints, because a function is never differentiable on its endpoints. So this is always on the open interval here. Condition 2 is met. The third condition is that the function evaluated at the left endpoint, a, has to match the function evaluated at the right endpoint, b. In this problem, the interval is -2 to 4. The left endpoint a is -2. The right endpoint b is a 4. So we need to evaluate the function f at the left endpoint -2 and the right endpoint 4. Each of these are evaluated by plugging into the function. So f of -2 will be -2 to the fourth power minus 4 times -2 cubed minus 2 times -2 squared plus 12 times -2. -2 to the fourth becomes positive 16 minus 4 times -2 cubed, which will be a -8, minus 2 times a -2 squared is a positive 4, and then a positive 12 times a -2 is a -24. This will give 16 minus 4 times a -8 is a plus 32. Minus 2 times 4 is a -8, and then minus 24. 16 plus 32 is a 48. Minus 8 is a 40. Minus 24 is a 16. F of 4 will be 4 to the fourth power minus 4 times 4 cubed minus 2 times 4 squared plus 12 times 4. 4 to the fourth power, 4 times 4 is 16, another 4 will make 64, and then one more 4 will make 256. Minus 4 times 4 cubed, which is a 64, minus 2 times a 4 squared, which is a 16, and then plus 12 times 4, which is a 48. This will give a 256. Minus 4 times a 64 is minus a 256, so those will cancel. Minus 2 times 16 is a minus 32, and then plus 48. So the 256's can cancel, and so minus 32 plus 48 is a 16. We do have that f at the left endpoint, -2, does equal f at the right endpoint 4. So condition 3 holds true. All three conditions hold true here. And Rolle's theorem does apply. Rolle's theorem says the slope of the tangent line evaluated at some value c will equal to, according to the mean value theorem, the slope of the secant line connecting the endpoints, f of b minus f of a over b minus a. For Rolle's theorem, we have the third condition also holding true, f of a equals f of b. And therefore, if we subtract the two from each other, it equals to 0. So Rolle's theorem is the special case of the mean value theorem where the slope of the tangent line at some value c equals to 0. And this will hold for at least one c, maybe more, in the open interval. So we're going to try to find all c values that have a slope of tangent line equal to 0 that end up in that interval. The left side, f prime of c, is evaluated by plugging c into f prime of x. That will be 4c cubed minus 12c squared minus 4c plus 12, and that should equal the right side, which is a 0. We have a 4-term cubic polynomial here. We can attempt to factor this by group factoring. We will group together the first two terms and group together the second two terms. For the first two terms, there's a common factor of a 4 as well as a c squared. That will leave behind a c and a minus 3. And the second two terms is a common factor of negative 4, and that'll leave behind a c minus 3 also. And therefore, there's a common factor of c minus 3 that can factor out of both of those terms. If we factor c minus 3 out, it will remove each of these. But there's also a common factor of a 4 that can also be factored. If we take the 4 out as well, we remove that 4 and the c minus 3 from each, leaving a 1 for that term. And so we will be left with the c squared and the minus 1. And this equals to 0. C squared minus 1 is a difference of squares and can further factor. So 4 times c minus 3 times c plus 1 and c minus 1 equals to 0. Each of these can equal to 0, so that we have c values of 3, negative 1, and positive 1 solving this. We want to see which ones of these fall in this interval. We're guaranteed at least one will, perhaps more. We'll look at each of them and determine if they fall within that interval. Well, 3, the first one, is in that interval. It's less than 4, definitely bigger than negative 2. Negative 1 is at an interval because it's greater than negative 2. 1 is in the interval because it's between negative 2 and 4. It looks like all three of these are kept. And there is all the values of c that satisfy the conclusion of Rolle's theorem for that function.